right, folks, it is about that time. Microsoft Ignite 2022, Seattle, Washington. We back. I'm sure this is not the first time you've heard this today, but this is the first time in a global pandemic that I have been in front of an Ignite audience on an Ignite stage. I'm so happy to be here. I'm so happy to have all of you here with me. Time is a truly non-renewable resource, and I thank you for sharing some of yours with me today. Now, Rick and Pierre had mentioned that in that 66-slide scrolling thing, this was the most important. Whoa, come back. No, stop, calm down, it's okay. This is the most important slide. So if you have not yet joined the online form, why are you auto-advancing on me? I love technology. So anyway, this is our QR code so that you can join the bubble. And apparently it just really wants to auto-advance, so I'm gonna let it. Hello everyone, my name is Laura Hunter. For those of you who have not met me, I am a principal program manager inside of the Azure Customer Experience Program. My pronouns are she, her, and hers. I am a 5'5" cisgendered Caucasian woman with short brown hair, wearing blue jeans and a black t-shirt, AKA the Seattle uniform. So that is who I am. Who do I think you are? Who did I gear this talk towards as I was putting this talk together? My assumption is that you are somewhere between a Linux dabbler, a Linux enthusiast, a Linux admin in some sort of heterogeneous Windows/OSS open source environment. And why is that important? That is important because there are absolutely valid use cases where you might take the whole of your Linux infrastructure and forklift it en masse into an Azure data center. You bring your workloads, you bring your applications, you bring your management, all of your management and your security tools, and you effectively become this island of Linux that happens to be running on Azure compute cycles. This is a completely valid use case. And if you are doing this, I thank you for doing this because I like my stock price. However, that is not why I believe that most of you are here, by virtue of the fact that you have come to Microsoft Ignite. My assumption is that you are coming to Azure for a reason. You have come to Azure because you want to take advantage of the management, the monitoring, the security capabilities that come with the cloud platform, and you want to be able to apply those capabilities across the whole of your Windows and your Linux estate. And so these are some of the things we're going to be talking about today. This is the direction I'm going to be going in. If you had maybe thought I was going to be going in a slightly different direction, I can close my eyes and count to 5, and I pinky promise I won't be sad. If you run out I'll be a little sad. Cool, you're all still here. I'm very happy. So what are we going to talk about today? We are going to be talking about some common troubleshooting issues that you will run into as you are bringing your Linux virtual machines into Azure IaaS, into Azure Infrastructure as a Service. We're going to be looking at some of these troubleshooting issues. We are going to be looking at some ways that you can take these sometimes very convoluted user experiences and make them a great deal simpler for your users, for your customers. And then at the end, we will talk about, frankly, what I call the easy button for Linux management and monitoring, as well as Windows management and monitoring. We'll get to that in a moment. Quick housekeeping note, similar to Oren in the previous talk. I do have some demos. I'm going to try, because I like live demos, but if I pop up the Azure portal and I get the spinny wheel of death, I don't know how the connectivity is today. If I get the spinny wheel of death, I am going to fall back on screenshots, videos, and interpretive dance, because I do not wish to frustrate you or myself by dealing with the Azure spinny wheel of death. But fingers crossed, let's get going. So in terms of troubleshooting Linux, and specifically around troubleshooting Linux virtual machines inside of Azure IaaS. When I first came up with the idea for this talk, I had a plan. there's a saying about plans. My plan for this talk was that I was going to go to my folks inside of customer support, inside of Microsoft CSS, and I was going to ask them, hey, CSS people, what are the top 10 issues that people get routed to our Linux queue for? What are the top 10 issues that people call into CSS for around the management and monitoring of their Linux VMs? What are the top 10 issues? And then we can go over in this talk today, here's the thing CSS would have told you to do anyway, let me save you the call. As it turns out, data is interesting. As it turns out, when we actually look at the call drivers around Linux infrastructure support, there is one big call driver for Linux virtual machines, and then a bunch of rounding errors. Interestingly, it's the same really big call driver that you see in the Windows IaaS space. I'm seeing a lot of grins, so I'm betting you can all figure out what it is, which is, I've deployed this virtual machine out into my Azure subscription. I deployed it. I picked an image from the marketplace. I deployed this VM. It's sitting in my subscription. I can see it in the portal. I'm trying to remote into it, and I can't connect. Couldn't connect is the #1 call driver in the IaaS space, regardless of operating system. Now, you might look at that couldn't connect label, and you might say, that's a really broad label. There's a lot of different reasons why you might not be able to connect to a VM. There's a lot of different things that might go wrong that would prevent you from connecting to a VM. You would think that, and you would be right. And so what we're going to do is we're going to walk through the kind of a systematic approach to some of the reasons why you might have issues connecting to your Linux VMs, your Linux IaaS resources. We're going to start kind of simple, and then we're going to get a little more in-depth as we go along. Okay, whoever had slide 8 in when are we going to see the OSI model in the troubleshooting talk, feel free to take your shot of espresso. But why do we start here? We start here because when you are running virtual machines inside of Azure, be they Linux, be they Windows, at the end of the day, the cloud is just someone else's data center. It's mine. I'm making all the money. It's beautiful. I love it. Thank you all for spending your money with me. And so when we think about troubleshooting access issues between your local machine and a virtual machine running inside of Azure IaaS, it's probably somewhere in here. So we start at the bottom and we work our way up. Here's the good news. If it's one of those bottom 2 layers, you know, those bottom 2 layers that you had to memorize of this whole model to get your CCNA certification or maybe your old MCSE, if the problem exists in one of those 2 layers, it's not actually a problem. It is a problem. It's called Azure is having an outage. It's not a problem that is necessarily yours to directly solve. We could go into any number of pieces of advice around designing your applications for geo-redundancy, for fault tolerance, et cetera. That could be a completely different talk. That could be a talk all on its own. As Aaron said in the last talk, if these are kinds of topics that are interesting to you, please do fill out your evaluations at the end. After the bottom 2 layers, it starts being your problem. Shout out to Casey Clemson for my favorite sticker in the world, because it's always DNS. Here's where things get a little different. Now, in the on-premises days, raise your hand if you ever lost 30 minutes, an hour, maybe more than that, of your life troubleshooting an access issue because you forgot to do something really simple. You forgot to just ping the machine or trace route the machine to make sure it was up. I'm seeing 25% of the hands in the room going up. I think the rest of you are lying. Good, there's half of you. We're being a little honest with each other now. I like it. So, why do I bring this up? I bring this up because, as I said at the start, I assume you came to Azure for a reason. And one of the reasons you come to Azure is when you deploy your resources inside of an Azure subscription, when you deploy any Azure virtual network, you receive a default security policy, a default what's called a network security group, an NSG, that is functionally akin to a set of firewall rules. And there is a default set of firewall rules that gets applied to every NSG that is deployed inside of Azure. You can augment these, you can create exceptions to them, but this is what you get by default. This reads like a list of firewall rules, and it behaves like a list of firewall rules. Every rule has a priority. Higher priority rules outrank the ones that are outrank the ones that fall below it. So as I run down this list, if you read the names, they're kind of self-explanatory. If I look at inbound traffic into an NSG, I'm going to allow all inbound traffic within the virtual network. So machines inside the virtual network can all speak to each other. I'm going to allow inbound traffic from the Azure Load Balancer service so that Azure Load Balancing can work. And then the last rule that gets applied, so the lowest rule on the chain, is deny all inbound. So if it wasn't one of the first two, it gets denied. Similar for outbound. I'm going to allow outbound traffic from the VNet. I'm going to allow outbound traffic from the VNet to the internet, and then just sort of as a catch-all at the bottom, anything that wasn't included in one of those two things gets denied. So this is your default security set, security rule set inside of a network security group. It has a very obviously deny by default mindset to it, kind of a good thing in the cloud. And what this means from a troubleshooting perspective is something like a ping or a trace route isn't going to help you that much, and that's probably a good thing. What we have instead, so what we have instead to allow you to do layer 3 network layer troubleshooting inside of Microsoft Azure is a service that is called the Azure Network Watcher. The Azure Network Watcher is a regional service, so it is deployed per Azure region. So anytime you deploy resources inside of a new Azure region, a new instance of the Network Watcher is going to be automatically deployed on your behalf. You can turn this automatic process off. So if you are working inside of your environment, or maybe if you're a consultant and you are working inside of a customer environment, and you pop open Network Watcher and, hey, I'm not seeing Network Watcher instances in regions where I think I should. You do have the ability to turn off this auto-population of Network Watcher. If you run into that situation, you can manually create Network Watcher instances, or you can turn auto-creation back on. Turning auto-creation back on is a CSS ticket, unfortunately. And now for the first demo. Everyone hold your breath. Woohoo! All right, so we have Network Watcher. This is the Network Watcher blade inside of the Azure portal. And what we see for the troubleshooting capabilities that are offered by Network Watcher, you have a number of capabilities that are offered inside of this blade itself, but we're also going to see that these tools and these capabilities get surfaced and get bubbled up elsewhere in the portal. We try to put the tools in the places where the tools make sense, so that you don't necessarily have to remember, oh, I need to go to Network Watcher to find this one thing. So to give you some examples of the kinds of capabilities you see inside of Network Watcher, we start with the network topology generator. And this gives us a very Visio-like view of the resources inside of a particular virtual network. So we can see this. We also have this is called IP Flow Verify. And what IP Flow Verify is going to do is it is going to allow you to simulate a piece of inbound or outbound network traffic. Can this VM talk to this machine outbound to this IP address on this port? Can this machine that's sitting out on the internet talk into my machine on this IP address and on this port? And it's going to, effectively, it's going to model the network traffic for you, and it's going to let you know if that if that piece of traffic would be allowed. Give me my resource group. It would help if I could type. Singing helps. And so, for example, I'm going to grab one of my demo machines, and I can see that it has popped up the internal IP address of that demo machine. I'm going to give it an ephemeral port as the local port. I'm going to grab an IP address. This happens to be one of the IP addresses of www.bing.com, and my question is going to be, can this machine talk out to Bing on port 80? I'm going to say check. I'm going to get an error message. Luckily, I knew this was coming. It was intentional, which is why I'm not panicking right now. So if, I apologize, the text might be a little bit small, but what you are seeing is error code, virtual machine not allocated. And in this case, what this means is this is a VM. You may guess from the fact that I called it shutdown that I turned off for the purpose of this demo. If this had been an actual connectivity issue, this would be the moment where I said, oh wait, I'm dumb. This machine's not running. Let me get it moving. So that gives you one view of one of the network troubleshooting tools that you have access to inside of Network Watcher. The next one is called NSG Diagnostics, Network Security Group Diagnostics. I'm actually going to pop over to the virtual machine blade itself to show you a different location where this capability is surfaced. So if I go over to the virtual machine blade, let's say I want to connect to this machine via SSH. Now, you're going to see something happen on the screen because this is live. It may happen really fast, in which case I'm going to pop up some screenshots just to give you some detail, just so you know what you're looking at. So I want to SSH into this machine, and you can see that Azure is making certain checks for me on my behalf. I am looking at the network security group for inbound access from my client IP address. The other two things you didn't see because it popped up really fast was, is the virtual machine running? Haha. And does it have a public IP address assigned? In the case of this machine, I get the great big green checkbox. Hey, we've run these checks for you. We are pretty confident that this SSH connection is going to go through. Have at it. As opposed to another VM that I called no SSH. What do you think this one's going to do? Ha ha ha. See, I try to make things easy. In this case, when I provisioned this machine, I explicitly disallowed inbound SSH in the network security group rules, for the purpose of this cooking demo. So again, I go to SSH. It starts running its checks. Hey, the VM is running. Hey, the VM has a public IP address. I'm looking for the network security group for inbound access. Port requisite not met. It then allows me to, from here, should I so choose, go directly to managing my inbound network security rules. So managing my inbound NSGs if I wanted to make that change. So all kinds of interesting stuff that you can do with Network Watcher. Now, we've got the connectivity going. We are listening inbound on port 22. Our next step is to actually fire up SSH. What is the first time end user experience with SSH connectivity? What's the first thing you do? You download PuTTY because you remember using that to SSH into machines when you were in college. Okay, go out to Google or Bing, find PuTTY, download it, install it, poke around on the interface until you remember where the spot in the config setting is where you need to specify where your private key is, and you pop in your and you go to browse for your private key. I'm not in slideshow mode. Oh dear, let me fix that, shall I? Thank you, my friends from the audience. There we go. Thank you. So, Now I want to browse to my, my private key. I browse to the .pem file for my SSH key, which is the file format that Azure gives me my private key in when I deploy a VM. Putty wants a .ppk file. What the heck is a ppk file? Okay, I'm going to go Bing. I am then told that .ppk is the file format for private keys that Putty wants me to use. And here is this puttygen.exe command line tool that you can run to convert your .pem file into your .ppk file. You start to wonder whether you really need to run Linux that badly. And then someone reminds you that Windows has had a native open SSH client inbuilt to the operating system since Windows 10. And then you pretend you did not just has the dumb, and you just go to your Windows box and start to do your SSH. And so since Windows 10, there has been an open SSH client built right into Windows. It's right in the command line path. You can just click Start, type SSH, and you have your command line. This is a very traditional SSH client. So SSH-I, give it the path to the private key, give it your username, give it the IP address or the FQDN of the box that you're attempting to connect to, and poof, you have SSH. Now, that works super well for one person, maybe a couple of people, maybe a small shop. But SSH is one of those technologies, frankly, any technology that's built around PKI is one of those technologies where if you look at the dial between security and usability, SSH is all the way on the secure side. Public key encryption is a super secure option for accessing your devices. You don't have passwords going over the wire. It's great. But from a usability standpoint, what's a public key? What's a private key? Oh, I just got a new box from work, and now where did my private keys go? And now how do I get it back if I lost it? From a usability standpoint, SSH, native SSH, it needs a little help. It needs a little work. And so one of the capabilities that you have when you bring Azure along for the ride is you now have Azure Active Directory, which is the Azure Authentication service that backs Azure, that backs Office 365, that backs all of our online properties. One of the capabilities that Azure Active Directory brings to the table is Azure Active Directory can function as an SSH server. It can function as an SSH head for your Linux boxes or for your Windows boxes that you may be running SSH on. And so from a usability standpoint, this is awesome. It pretty much takes all the PKI crazy away from you, all the key management, all of the deploying public keys versus private keys, short-lived keys, long-lived keys. Azure does it all for you. And it does this by way of an extension that gets deployed to your Linux boxes. That extension includes a PAM, a pluggable authentication module that will allow your Linux boxes to then speak SSH to Azure Active Directory. You have the ability to configure AAD authentication as you are creating a virtual machine. You can see these two checkboxes, log in with Azure AD, and if you select that option during at provision time for your virtual machine, everything gets handled for you, or you can come in after the fact and take care of it that way. There are some limitations around the supported distributions and versions of Linux that will support this capability. We have those listed up on the slide. There are certain VM requirements, the biggest one being that pluggable authentication module, so that AAD SSH login module needs to be installed, which Azure will handle for you, or you can use the AZ client after the fact to install that for you. There are also certain RBAC requirements. So in order for a user to use AAD SSH to log into a virtual machine, that user needs to have either the virtual machine user login or the virtual machine administrator login RBAC role assigned to it. This is an explicit RBAC role assignment. Even if someone is an owner or a contributor on that VM, they do not receive this role. They do not receive this role automatically. It is an explicit separation of duty that needs to be assigned. If, like me, the first time you try to get this running, you forget to do the RBAC part, you will try to SSH into a box using your AAD credentials, and you will see permission denied, public key, and then you will get angry, and you will go to Bing, and say, why isn't this working? And then you will realize, oh, I need to go give myself a role. Once that is done, so once you have all of those prerequisites in place, again, you can use just the normal SSH syntax. Actually, at this point, you would use AZ, the AZ CLI tool, and you would use AZ SSH, resource group, give me the resource group name, and then name, and give me the VM name. I also like this because it takes the IP address FQDN consideration out of the way. As long as I know the name of the VM as it is configured inside of Azure, I can SSH right into it. So there are some setup requirements from an administrator standpoint, as there tend to be, but it creates a much simpler, a much smoother end user experience. And so is the RBAC thing a little fiddly? Is deploying the client extension a little fiddly? It can be, again, from an administrator perspective, but it creates a much smoother end user experience. Now for the fun part. We even want to get rid of the fiddly administrator experience. And so one of the things that we are working on, and you are about to see a private preview experience inside of one of my internal subscriptions. All caveats apply to internal preview builds. Cross your fingers, it worked an hour ago. We are working on an experience around connecting via SSH inside of a browser. We call it one-click connect. You can see we're under Microsoft Azure Preview. And what we see here is from inside of the Azure portal, I go to the connect option on the left-hand side of the menu, and I see this is new, connect via SSH in the browser. I click connect, and the portal says, hey, you're almost ready to connect. You need the SSH login extension. You need this virtual machine login role. You need port 22 enabled for you. Hey, would you like me to go do that for you? Well, yes, I really would. And then we cross our fingers and connect, because again, this worked an hour ago. I love live demos. Important to note that especially around the assignment of that virtual machine login role, we will only assign that role if the user is eligible to have that role anyway. So if a user is already an owner, is already a contributor, we will assign that role on their behalf, but there's not any sort of escalation of privilege here. We are honoring Azure and Azure AD constructs here. It worked. I'm so happy. And we are requesting a Cloud Shell. We are connecting a terminal. And hey, look, AZ SSH VM. There's my resource group. There's my VM name. And there's my subscription. This is the first time I have connected to this machine, so it gives me the eternal, hey, I've never seen this public key fingerprint before. Yes, I would like to connect. And hey, look, I'm SSH'd in from one click in the browser. Or I should say, JB Barnes is connected, JB Barnes being my default test user. Anyone who can come up to me afterwards and tell me why, I will buy you a cup of coffee. So that's one click in the browser. That is in preview today. We expect to see this rolled out to all Azure regions month-ish. Functionally done. We just need to get it rolled out to our various regions. All right, what else have we got? Some more Azure Active Directory goodies that come along for the ride when you deploy your Linux VMs inside of Azure. One of the other things that comes along for the ride with Linux is something called Azure Active Directory AAD Conditional Access. Are folks familiar with conditional access? About half the room. Okay, so for some of you, this won't be new. Conditional access is a service inside of Azure Active Directory that can provide additional layers of security that control who, when, and how your users can access cloud-based resources. Some very typical examples that can make this real for you. If you are coming in from a non-corporate device, so if you're coming in from a non-managed device and you are trying to access Office 365, we're going to want you to do multi-factor authentication. Or we only want you coming in from a corporate managed device, and we are going to disallow personal devices for a particular application. For a higher security application, I might set hours of the day. I might set device health checks. All of these different conditions that I can apply to how my users are accessing my cloud resources. By bringing your Linux VMs into Azure Infrastructure as a Service, your Linux VMs become one of those resources that can be managed and manipulated by Azure AD Conditional Access, which I just think is super cool. And so you can see we have here just a prototypical conditional access policy. I've named it Linux-Ignite. I am assigning it to specific users, so I have specific users that I want this policy to apply to, and I want to have this policy apply to Azure Linux VM sign-in. Any virtual machine inside of your Azure subscriptions is going to be able to be controlled, and it's going to be able to be modulated by Azure AD Conditional Access. And in this case, I am going to grant access, but then I can apply additional conditions before I grant access. I can require multi-factor authentication. I can require different strengths of multi-factor authentication. Maybe I say Windows Hello has a certain level of strength, where an SMS to my cell phone has a different level of strength, where a password has a different level of strength, and I can start making these authentication strengths differentiations and making access control decisions on the basis of it. Maybe I need the device to be marked as compliant, and my definition of compliant is something that I can assign as an organization. I can say what compliant means. Maybe I need that device to be running anti-malware. Maybe I need to have up-to-date Windows patches as of a certain date. And if that device is then not considered compliant, I can then make access decisions. I can prevent you from accessing O365. I can prevent you from accessing your production Linux VMs, your production Windows VMs. So again, this is super cool, and this is one of those really incredible security advantages that you have when you bring your infrastructure, so your virtual machines, into Azure Infrastructure as a Service. And again, this can apply to your Windows VMs. This can also apply. This will apply equally to your Linux VMs. And this is kind of the culmination of why we want to bring Azure Active Directory SSH into our Linux environments as that authentication provider, because it means that we get all of this security goodness that our O365 people are getting with Azure AD anyway. I'm getting automatic provisioning. I'm getting automatic deprovisioning. I don't have to worry about proliferation of private keys, and what if someone took that PEM file and walked home with it? And do I need to remember to deprovision them? And all of this goodness that comes along with Azure Active Directory now applies to your Linux estate. Super exciting, very cool. Azure Serial Console. So Azure Serial Console is a troubleshooting tool that is built into the Azure portal, and it is meant to address the problem of I need to VM into the machine, but the machine is unhealthy enough that I can't get to it. I need to remote into a machine that is not remotable. And so the Azure Serial Console gives us the ability, and again, this is only accessible inside of the Azure portal. It gives you the ability to log into what amounts to a recovery console for your Linux machines. The account that's using Serial Console needs to have that VM contributor role. Your VM needs to have boot diagnostics enabled. This can be set up at boot time, or you can do it inside of the Azure portal after the fact. That middle bullet can be the stickler, which is to say the VM in question, if you need to get in and run those sorts of Serial Console diagnostics, it must have a password-based user, which can create something of a chicken and the egg, where if you have deployed SSH broadly as a good security practice, because it really is, what happens if I need to, wait 1 second. Where is my Serial Console? There you are. As I say, singing helps. And so I'm clicking on Serial Console inside of the Azure portal. And I'm going to wait. And here we go. I'm now looking at what amounts to a recovery console for my Linux box. Most people don't remember that they need a password-based user here until they get prompted for a password. And then they say, wait, what? I use SSH. What are you talking about? You have two options at that point. You can use the reset password capability inside of the Azure portal, where you can set a password-based login for a particular user, or you can use the AZ CLI to set a password for that user at the command line. Obviously, once you are done, please go back in and scramble the password, delete all the good security things. I don't have to tell you that. You're all very security conscious humans. Are you back? Yes. Helpful commands for the Serial Console: how to create that user password, azvm user update, resource group, name, user, password. I can't believe it's in plain text. Sometimes you have to type things. Another just sort of very quick little command that will often be the only thing that you really need to save you when you have a VM that is in this state is really just restarting the SSH daemon, and that is a very simple AZCLI command: azvm user reset-ssh, give it the resource group, give it the VM. Life is good. Now, here's what we're going to finish with, and this is just sort of a kind of fun, cool thing. I need to look at the clock, and the reason why will be evident in a moment. Okay, all right. Jeremy Winter is doing a keynote speech in another room right now. I thank you all for being here. I was afraid I was going to have an empty room because Jeremy's a lot of fun to watch. Jeremy is talking about this service here. The service I'm about to talk about, which is called Azure Auto Manage. As of today, this service is in general availability. Jeremy announced that about 6 minutes ago. I needed to not beat him to the punch. I like my job. I like not getting calls from marketing saying, Laura, why did you? I was looking at the clock. See, you're all my witnesses. So when we think about how to manage your infrastructure as a service, how to manage it, how to optimize it, how to monitor it, how to update it, how to keep it backed up, all of the good things. There are so many different services that you need to keep track of. There's Azure Backup, there's Microsoft Defender, there's Azure Monitor, there's Azure Updating, there's change tracking, there's inventory, there's automation, there's configuration management, and there are people who get paid a great deal of money to go through and figure out how to configure all of these different tools. But you you want to be doing more interesting stuff than just configuring backup over and over and over on a VM. And so what Azure Auto Manage allows you to do is Azure Auto Manage creates a suite of configuration settings. So basically, a profile of configuration settings that we have looked at. We have looked across, the breadth of Azure VMs running across the whole of the service, and we have put together several default templates of what we consider best practices for production machines, as well as for dev test machines. The reason we make the distinction being, we assume that dev test machines might not need quite as robust in terms of backup services, in terms of monitoring, and so we've made these distinctions between dev test and production. And so we have put together these configuration profiles of all of these different services inside of Azure, and we've created a service called Azure Auto Manage that will go out and apply these configuration profiles to your virtual machines, Windows as well as Linux. They will apply these settings, whatever settings that you configure in this configuration profile. You can use one of the ones that we've created as a default. You can customize your own to your heart's content. Azure Auto Manage will apply all of these settings to your VM, and far more importantly, in my mind, it will monitor that VM over time, and if it detects configuration drift, if someone turned off updates, if someone changed the backup configuration, if someone turned off monitoring, Auto Manage will then come in behind that change and remediate it. It will bring it back up to snuff. It will bring it back into that approved configuration profile. Azure Auto Manage as a service is free. There is no cost attached to it. The only costs that you will see are any costs that are associated with the services it is bundling. So if you use Azure Auto Manage to configure Azure Backup, you're going to incur the backup costs. If you configure monitoring, if you configure log analytics, you will incur the log analytics costs. You will incur the storage costs for log analytics. But Auto Manage itself is not a service that we charge for. We want you to have secure and well-managed VMs, because that makes for a very healthy and happy Azure, which makes for a very healthy and happy internet. Now, in terms of Windows versus Linux, you can see the various configurations that are available for dev test on Windows, dev test on Linux, production on Windows, production on Linux. Obviously, we want to evolve this capability matrix over time. You will also see, and this is out on the Windows doc site. There's also a bit of a Venn diagram sort of twitchiness when Azure Arc comes into play. So if you have machines that are managed by Azure Arc, they can also play in the Auto Manage space. But again, there gets to be sort of a interesting little support matrix. Again, we want to make this fuller and more complete over time. Enabling Auto Manage. Where did you go? Where did my Auto Manage go? Singing helps. Auto Manage. See that little preview? That's going away very soon, because it's GA as of today. And so when we go into the Auto Manage pane inside of the VM blade, the first thing that it will do is check to make sure that this particular VM is eligible for Auto Manage. Usually that's a function of, are you running a supported build? I can choose which configuration profile I want to run, and then I can deploy Auto Manage. Obviously, you want to do this for more than one VM at a time, and when you want to do that, you will do that via Azure Policy. We have lots of built-in policies configured for Auto Manage to deploy the out-of-box configuration profiles that we've created, or to deploy a custom profile that you have created. So that is Azure Auto Manage. It is in general availability as of today. It applies to your Windows and your Linux estate. It is the easy button It is really, really great. I think it's one of the most amazing things that we've built in really rather a long time. If you want to learn more about it, go to this session in this room at 3 o'clock. There is another session in this room at 2 o'clock about something very interesting. I just don't happen to know what. So that is what I have to talk with you about today. Again, thank you all for having me. I will be out on the Sky Bridge for a little while after the talk. I do need to vamoose to let my next speaker up here. Again, thank you so much for having me. It is so great to be back at Ignite. I'm so glad that you are all here. If you liked what you heard, please tell the conference organizers. If you didn't like what you heard, please tell me, and we'll make it right for you. Thank you so much.